Okay, we're going to talk about physical properties of matter. First of all, you got to know two things. Matter is anything that has mass and takes up space. That means air, water, plants, animals, everything that is on our earth is matter. Also, you have to know that physical properties can be measured and observed. These things will not change ever. If you crumple up a piece of paper, it's still going to be a piece of paper. It's still going to have the same amount of matter. Because you changed its shape does not mean that it changes what that matter is. Let's look at mass. First things first, mass is made of particles. You can think of them like tiny little spheres that bunch together and they create either a solid, a liquid, or a gas. So the amount of matter depends on what type of matter, whether it's solid, liquid, or gas. Water is going to have, how about this? We'll start with solid. Solid's going to have the most amount of matter. It's closely packed. It's very dense. Water is going to have a little bit less. The particles are able to move around, and they don't just have to stay in one place. The state of matter with the least amount of particles is gas. The particles are spread so far apart, it's hard to even weigh them. A lot of the times, people confuse weight with mass. They are not the same thing. Mass is how much matter something has, and weight is the pull of gravity on an object. For example, the Earth. The Earth is big, so it has a lot of gravity. That gravity is pulling us and everything that we can hold or touch or feel down with it. The more mass something has, the more gravity it has. That is the only way these two things are related. A lot of the times we talk about weight and gravity being the same thing, and like I said earlier, that's where we get confused. They are not. If you had a flag and you put it on the moon, it is going to be the same amount of matter being taken up on either the moon or the Earth. It takes up the same amount of space. The difference is their weight because the pull of gravity is less on the moon than it is on the Earth. You already know the moon does not have as much gravity as we do. Volume's pretty easy. It's just the amount of space that an object takes up, whether it's sitting in a room or sitting in a bucket of water. You might remember when we put the density cubes in water in a graduated cylinder. Excuse me. We fill the graduated cylinder up with water. You can see where the first line is, or the second, depending on which way you're looking at it. The line that's touching the arrow is where the water was originally. It moves up, which is why the arrow is moving up, to the next to the next line, meaning that this cube would have had 1 milliliter of volume. You can also measure volume with centimeters, millimeters, or liters. That just depends on the shape of the object. If it's a cone, you're going to measure it differently than you would a cube. As you guys know, some types of matter are magnetic. Magnetism is just the attraction between two magnetic things, between either a magnet or a magnetic force. There are only a couple types of metals that are magnetic or that are attracted to a magnet, however you want to say it. Nickel, cobalt, and iron are a few. Steel's one. Next would be conductivity. It's just metals conducting heat or electricity. Those are conductors. If you have an insulator, it's not allowing heat through or electricity. One example of a conductor that's really easy is a wire. Wires are made of metal. That metal, when you attach it to a battery and then to a light bulb and you make sure that your circuit is complete, will cause a light bulb to turn on, which generates electrical energy. It also generates thermal energy because that bulb will eventually get hot. An example for an insulator would be rubbers on wire. That rubber's there to protect you so that you don't shock yourself with the electricity that's coursing through that wire, or that you don't burn yourself. When you cook at home, hey, try cooking this week. When you cook at home, you might use a rubber spatula, or use a rubber glove to pick up a pot or a pan. That's so you don't burn yourself. One second. Thank you.
You're welcome.
Take the whole bag.
And you shred it,
All right, thank you. Have a good day. You too. Okay, you have your water. That is your solvent. You are going to pour things into your water and mix it up. The water is called a universal solvent because most things will dissolve into that water. That's all this is. Will something dissolve? So you have your solvent, which is your water, your Kool-Aid, your lemonade, whatever kind of mix that you grab, salt, sugar, that is your solute. You're going to pour it in, close the lid on your bottle, and I want you to just shake it. Shake it until you're completely dissolved and see what happens. If you have a colored mix, you should see only one color in your bottle when you're done, whether it be red, yellow, green, blue, doesn't matter. That shows that it is a solution. Every part that you put in, the water and the mix, are evenly mixed in, and you can't tell them apart. It's also going to be extremely, extremely hard for you to separate it. If you can't tell by the color, and you're brave enough, go on ahead, open your water bottle. You should have only put household appropriate items to eat or drink in here. And taste the water. If it's sweeter, if you put sugar in it, or if it's salty, if you put salt in it. Last thing I want to talk to you guys about is density. Remember, well, here, how about this? We'll start with what is density. It's the amount of matter in a certain volume. So you take a tank or a tub or a bowl or something, fill it up with water. Excuse me. Fill it up with water and pick some household items that your parents say are okay to put into water. I'm not telling you just do this and then get yourself in trouble. So let's say you had a ball and it's sunk to the bottom of the floor. That would mean that this ball is more dense than water. We only know that because it's sunk. Let's say you took a ping pong ball, because I know for a fact those will float. You took a ping pong ball, you stuck it in the water, and it sat on the top. That tells me that that ping pong ball is less dense than water. Anytime we talk about density, we're always referring to it with water.